All real numbers can be located on a number line. This means that all irrational numbers can be located on a number line. You can use a number line to graph and order real numbers.
Okay, this is where we're going to compare rational and irrational numbers. We're going to figure out which one is greater between the rational and irrational. So we have the square root of 3. That's whenever you're going to put that in your calculator. And the square root of 3 is 1.73. So 1.73 is greater than 1. That's part A. Now, in part B, we're going to compare our rational number 1.5 because it's terminating, and our irrational, that's the square root of a non-perfect square. That means it goes on and on forever. So that's the square root of 2. Square root of 2 is approximately 1.4. So 1.4 is going to be less than 1.5, meaning 1.5 is greater than. Okay, going on to C. The square root of 12. Square root of 12 is approximately 3.46. So 3.46 is greater than 3. Now moving on to D. Here you probably want to go ahead and find out in decimal form 20 divided by 9. 20 divided by 9 is 2.2222 repeating. It's still rational because it's a repeating number. Now we're comparing 2.2 and the square root of 6. Now the square root of 6 is 2.4. So we know that 2.4 is greater than 2.2 repeating. E, this is some negatives. Now we may need to write this on paper. So we have so here we have this right here. Because this negative is on the outside of the square root of 7, we just would like to find the square root of 7 first. That's the same thing as just like multiplying negative 1 times the square root of 7. Okay, that's the same thing. So the square root of 7 is approximately 2.64, which is a negative, okay? So now what we're comparing here, we'll be comparing negative 2.64 and negative 2.6. Well, if this was all positives, then yes, 2.64 would be greater. But we're talking about negative, so if we draw our number line, we have negative 3, negative 2.5, negative 2, negative 1, 0. Okay, so we're going to see which one's greater. So negative 2.64 is going to fall approximately right here. Okay, that's negative 2.64. Now 2.6 is going to be super close. Negative 2.6. Okay, so which one's greater? Well, we know anything that's closest to 0 is greater. The number that's, I'm talking about the negatives, because this is further away from 0, so that's going to be negative 2.64 is less than negative 2.6. So therefore, which one is greater? Negative 2.6 is greater than negative 2.64. And we have to remember that negative 2.64 is representing negative square root of 7. Well, technical difficulties. Right, moving on to F. Alright, pi. What does this mean? Pi squared. Well, guys, we're just going to, you can use a pi symbol in your calculator, or you can use 3.14 to represent pi. So if I take 3.14 and I square it by using the calculator, I get approximately 9.85. We know that 9.85 is greater. Awesome job. Now moving on to 2 of 3. Not sure why this is not wanting to touch very well today. Which symbol correctly completes the statement? Once again, this is where we are going to simplify that fraction first. It's hard to compare in a fraction. We're going to turn that fraction into a decimal. So 4 divided by 3 is going to be 1.3 repeating. Well, so when we compare, that'll be and I want you guys to be finding out what the square root of 2 is. I found the square root of 2 to approximate to 1.4. We can read this. So which one is greater? 1.3 repeating, which is 1.33333 continuously, or the square root of, or comparing it to 1.4. And 1.4 is going to be greater, so the symbol that completes this statement should be the less than sign, just as shown. Okay, it's wanting us to compare. You're planning an art exhibit. One of the artists is a former math teacher. Each artist sent you the heights of their paintings. You want to display the paintings from shortest to tallest. So from least to greatest. Show how you display the paintings. Okay. Well, I'm just going to write these numbers over here on my own paper. So what we need to do first is we need to go through and these square roots, we don't have any fractions, so we need to turn these square roots into decimals. So 2.8 is already in decimal. Square root of 2, I want you guys to find out what that is in decimal form, which is 1.4, approximately 1.4. So we'll do this approximation sign. And then the square root of 5, which is approximately 2.23. 1.6 already in decimal form, and the square root of 7, which is approximately 2.64. Alright, so when we go to order these from shortest to tallest, which is from least to greatest, my least number of this is going to be approximation of 1.4, which is the square root of 2. Okay, and then next, I'm looking 1.6. So when we go to order these, though, guys, we want to make sure we're using the square root of 2 and not the approximations, which is 1.4. Okay, so 1.6 is next. Now, our least number would be, our next to least number would be 2. Then we would have 2.23, which is the approximation of the square root of 5. Followed behind the square root of 7. Followed behind 2.8. So we just ordered these from least to greatest. Basically, guys, you're just typing the square root in your calculator, turning it to decimal form, and putting them in order from least to greatest, or whatever the problem asks you to do. Just making sure you can know how to do square root form. Okay. I'm not sure why this is blue. But once again, it wants us to order from least to greatest. So the only thing, we have two decimals. We know that pi, I'm just going to do this on my paper. We know that pi represents 3.14. So we'll go ahead and change that pi to 3.14. We have square root 11, 3.4, and 3.1. Now the square root of 11 is approximately 3.31. Okay. No, I just now caught myself. I noticed that, oh, never mind, that's 3.31, not 3.1. Okay, we're good. 3.31, so we're going to do from, it says to do least to greatest. Well, we have to remember that this 3.4 and 3.1, that terminates. That's a terminating decimal, which is rational. So it terminates into zeros. So what follows behind these are zeros. So when I'm comparing which one's least out of these, I have 3.1 and 3.14. Well, our hundredths place is 0 and 4. I know that 0 is less than 4. So my first least number is going to be 3.1, followed behind pi, followed behind the square root of 11, and then the greatest number will be 3.4. That is order from least to greatest. The only difference we changed was to change pi to its approximation and change the square root of 11 to its approximation. Order the values from least to greatest. Continuing on, once again, I'm just going to do it on my paper, it's easier. Okay. The numbers we have, not in any form, is square root of 3, negative 17 over 4, negative square root of 17, negative 1.7, square root of 9, and 5/3. So I'm going to go through and take these square roots and fractions and turn everything into decimal form. It's my goal. So square root of 3 approximates to 1.73. Moving on. I know this is going to be negative. I'm going to go ahead and put my negative before I forget. 17 divided by 4. Well, it is exactly 4.25. Once again, negative. It's on the outside of the square root, so I am bringing it down before I forget. And I'm just going to take the square root of 17 which is an approximation of 4.12. So that's technically negative 4.12 because it's like you're multiplying a negative 1 out beside it. And then negative 1.7, we know square root of 9 simplifies to be exactly 3, and 5/3 reduces to decimal form. It is 1.6 repeating. So ordering these from least to greatest, we got to keep these negatives in mind. We know the highest negative is our least number. So the largest negative, let's go through and find the largest negative. The largest number that's negative will be 4.25. So that is going to be my least number. That's number 1. That's my least. Then I'm going to find my second closest largest negative, which would be negative 4.12. That's going to be my second to least number. Still looking at negatives. I want to do all negatives first because they're my least numbers first. That's going to be negative 1.7, excuse me. Now moving on into the positive range, 1.6 and 1.73. We know 1.6 repeating is going to be less than 1.73. This follows in behind, and our greatest number we have will be the square root of 9, which is 3. I have now ordered these from least to greatest. I have one more example. Just one more practice of ordering least to greatest. So I would love for you to pause the video and you try on your own and then just check it with mine. You don't have to watch me going all the way through it. So just keep in mind that our main goal is to turn everything into decimal form in order to compare. Okay. That's negative, supposed to be on that side. So this will be negative 4. I'll have to divide 16 divided by 6. No, it's going to be negative, which is 2.6 repeating. The square root of 8 is approximation of 2.828. And then we have 2.6 already completed for us. And the square root of 10, we know this will be negative, so negative square root of 10 is 3.16. Okay, now we have them all in decimal form in order to compare. Remember, the largest negative is the least number. So negative 3.16, that's our least number. Next would be negative 2.6 repeating. Oh, I messed up. I forgot the negative 4. Let's go back. Let's erase this. We can always catch our mistakes, okay? It's common to make them. So negative 4. That's actually going to be our least number. Negative 4 is less than negative 3.16. Secondly, we will have negative 3.16. Third, negative 2.6 repeating. And now which one is the least number of this is 2.6. And then approximately 2.8. We have now completed listing those from least to greatest. That completes the examples of this lesson 1.4. I'm going to once again show you the companion page, give you a little extra practice, and I'll give you the answers to check. This is just for your extra practice. Just pause it if you want to work through those. And now here are the answers.